Assalamualaikum and good day everyone. Today, my group and I will present our project titled Relationship between Part-Time Employees' Working Hours and Their Daily Salary. Our presentation is guided by the quote by Mahatma Gandhi, "The future depends on what you do today." So let's get into it.
This is my group members, Aira, Damia, MOHAMMAD, AZIZI, me, SHARIFAH, FARAH, SYED, and NADHEA, SAFFIYA, SHAHARUDDIN.
For now, I will explain about our background of study. So, part-time jobs are becoming more common, especially among students and people who need flexible working hours. These jobs help individuals balance work, studies, and their personal life. Since salary usually depends on the number of hours work and job type, working hours and income are closely related. This study is important because many students and young workers rely on part-time jobs for financial support. Therefore, our study aims to understand how working hours affect salary and income patterns among part-time employees.
Okay, now I'm going to explain to you guys about our project objectives. So first, we want to examine the relationship between part-time employees, working hours, and also their salary. So next objective is to apply least square method to analyze the collected data. And the third one is to find the best fit equation to represent real data. And lastly, to determine the correlation and trend between working hours, salary among part-time employees. And I'm going to explain our member comments. First thing first, we have three sections, which is plot points, linear approximation, and also error calculation. Okay, now I'm going to focus on plot points. So in Maple, we have to classify the comment first. So we have to change x into a matrix form. So we type in x equal to the data we have just now. And we get the answer is 4, 5, 5, 5, 7, 7, 8, 8, and also 9, 9. Same goes to y and a1. But don't go to a1 first because we're going to use it at linear approximation later. Next, we're going to focus on the graph. Now we can write a comment to produce the graph. Only the plot points because we're going to use it in the linear approximation also. So don't worry. Now we're going to the second section, which is linear approximation. Firstly, we find a, which is a combination of a1, x, and also x multiplied by x, and then dash the answer below the comment. And then we find b, which is the combination of a and y, and then we reduce b using reduced row echelon form, and we get the answer as below. As you can see there, row 5 until row 10 have no leading one, so we can conclude that this system is inconsistent. So we can proceed using linear approximation. Now it's time to find the linear approximation. So we have to find AT, which is A transpose, and the answer is as below. And then we can continue on finding ATA, which means A transpose multiplied by A. And there we go, the answer over there. And lastly, we find ATB, which is A transpose multiplied by Y, and there's the answer. Next, we find M, which is the combination of ATA and also ATB, and we get the answer as below. And also we reduce M using reduced row echelon form, and we get the answer as is, and hence we get the equation on the right. And now we can get the fully plotted graph over here. Just insert the comment as shown, which is b equal to plot in bracket yx equal to 1 until 10 close bracket, and display d and b. And that's the fully graph we get because this is the graph that we used at the plot points before. So we use it now in linear approximation, and we got the fully version of the graph. Lastly, we calculate the error vector. Just type in the comment ERR equal to y minus in bracket a multiplied by answer close bracket. ERR is indicate the difference between them, so the answer is as below. Last but not least, we calculate the magnitude error. Just write the comment and we'll get the answer, which is 46.10147503903877442. But as usual, we only use 2 decimal points, which is 46.10.
So next, we move to manual calculation to find a plus bx plus cx squared. Firstly, we move the equation into augmented matrix. Next, we use ERO to get upper triangle. And from the final answer, we can conclude that since row 4, 5, 6, 7, 8, 9 and 10 are all false statement, hence the system is incorrect. We move to the next step, which is we need to find A transpose A and A transpose B. At the end, we can get the answer for A transpose A is 10, 67, 479, 67, 479, 3607, 479, 3607 and 28247. Next, for the A transpose B, we get 719.5, 5061.5 and 3761.5. Next, we can find the value of ABC from the comparison between A transpose AX and A transpose B. At the end, we can find the equation of y equal to A plus bx plus cx squared. And we can get y equal to negative 4603 over 605 plus 119359 over 7260x minus 4637 over 7260x squared. Next, we need to find error. The formula for error is B minus AX. For the final answer, we get 12.065013, negative 11.1272727, 1.372772, negative 8.62727272, negative 4.179614333, negative 6.179614333, negative 3.03966442, 36.960333058, 1.377685950, and negative 18.622314046. Last but not least, we need to find the magnitude of the error, which is the square root of sum of square. So the final answer for magnitude of error is 46.10147.
In conclusion, for our analysis, both manual calculations and mapper comments produce the same values for A, B and C. The values are A, which is equals to negative 4,603 over 605. B is equals to 119,359 over 7,260. And lastly, C is equals to negative 4,637 over 7,260. So the magnitude of least square error value is 46.1015. Using the least square method, we studied the relationship between working hours and salary. The results show that employees who work more hours generally earn higher salary. Overall, the model is reasonably accurate and useful for analyzing real-life data.
That's all from us. Thank you!